So very good morning, everyone. Within 2-3 minutes, we will be starting our session 9:30 plus. Lim sir, we are very much pleased with your association with Bhupinder and with DTU as well. You have been a regular visitor, our source of encouragement and support all the time.
Well, my pleasure.
Good morning, sir. Good morning.
Is it time? Morning.
Within 2 minutes, sir, we will be starting. First, we will be introducing you with the participants. That the duty I will assign to Bhupinder. Good morning, Das sir.
Good morning, sir.
Good sir.
Good morning, Mohammad Irsad, Rajat sir, Dr. Sanjay,
Good morning, sir.
Naveen, good morning.
Sir, namaskar.
Neeraj, good morning. SM Parasar sir, good morning.
Good morning, sir. Good morning.
Very good morning. So, I request Dr. Bhupinder, who is also very good, very much a part of DC, DTU. So, I given him an opportunity to coordinate the introductory session. Yes, Dr. Bhupinder.
Thank you, sir. Thank you. So today we are having Professor HEECHANG Lim, who is working as professor in Pusan National University, South Korea. Professor HEECHANG Lim obtained his bachelor degree of science and mechanical engineering from Department of Mechanical Engineering from Pusan National University. The MSc and PhD degree in thermofluids mechanics followed from the Department of Mechanical Engineering of Pohang University of Science and Technology post-grad. Since 2003, he has taken a research fellow position in the School of Engineering Science of University of Southampton in UK. In 2006, he returned to South Korea and took up a position of assistant professor in the School of Mechanical Engineering, Pusan National University, Pusan. And since then, he is working as a professor there in Pusan National University and continue to develop his research interest in fluid dynamics, wind energy assessment, and wind turbine design, etc. His application include renewable energy like solar, wind, bio-hydraulic energy, aerodynamics, fluid mechanics, drag reduction, heat transfer, microfluidics, and so on. So he is a very senior professor having wide experience. So I also work with him as postdoc fellowship under him. And with this note, I also recommend all the participants here and faculties, respective faculties, that if they are having any promising student of their from their institute or from their belt, they can refer to Professor HEECHANG Lim. He is always there to help student, international student in Korea. If they want to pursue study in his lab, all students are always welcome for master degree and PhD degree. Thank you, sir. Now it's over to Professor HEECHANG Lim. So please, sir.
I'm sorry, this is mic was off. Thank you. Yeah, thank you for your generous introduction of myself. And my name is Professor HEECHANG Lim from South Korea. I'm working for Pusan National University last 15 years. And well, it's good to see you, all of you, actually morning in India. Actually here, so we all technically lunchtime. I just finished my lunch. So it's rushed to present my work. Actually, it's my pleasure good to introduce myself and then my work together with you. Right? Can I share my work actually?
Yes, sir. Beside the hand symbol, you have to click arrow. Yeah, now it has come.
Can you? Is it okay to see that one?
So just a minute. Yes, sir, it is clear now.
Okay.
You may make
Right.
it full screen, I think. Have you made it?
Okay. Oh, nice. Okay. Just to make it again. I think this problem. Okay. Try it again. What about these? Is it clear?
Yes, it's clear.
Okay then. Right, may I start now? Is this quick, how can I say, quick making of the presentation file for you guys, but it is part of the slide, maybe, not clear. So if I have problem to show you my slide, I will skip that one. So, well, this is my great pleasure to introduce some renewable energy area, in particular wind turbine stuff and wind farm stuff. So I give you some brief history of wind turbine and wind farm, and then the work, what we are currently doing in the wind energy sector, and probably some new things here in the due course. Okay, right, as you remember, the windmill, which was used in the past all time ago, and actually windmill, actually this one converted the wind energy into rotational energy by using vanes called the sails or blades. And then the reason for the name windmill actually is that the device originally were developed for milling grain in the countryside, even in the city. They need to eat food after making some production. Okay. Then it was adopted to supply power for many industrial and then agricultural needs other than milling. So after then, the name was converted like wind turbines. It's this one used in present now. And then you install many wind turbines we called wind farm. Okay. Actually, this wind turbine actually generate electricity. So converting kinetic energy actually from the wind into electrical energies. Okay, so that's why we feel comfortable. Maybe actually this comes from wind energy as well as some nuclear powers, etc. Okay, and then you connect these energies to the grid, actually electrical grid, to provide it in the city. Okay, right. Well, we have something brief history about the wind turbine. Actually, I told you windmills were used in originally the system Persia, now it's called Iran, as well as early as 200 BC. Okay, and then the windmill of Huron of Alexandria marks one of the first known instances of wind powering a machine in history. So after then, windmills appeared frequently in Europe during the Middle Ages. So after then, in England, manufactures these windmill or wind turbines 11th or 12th century. So Dutch windmills after in this period, and then they use this one as draining of water in the Rhine Delta. Okay. Right, the first electricity generating wind turbine was a battery charging machine installed in 1887 by Scottish academic James Bliss in Markirk, Scotland, which is in the UK actually. And then Charlie Brush, an American inventor, built the first automatically operated wind turbine for electricity production in the US. Okay. Well, there's after then, there's so many countries invest money and then use the wind as wind turbines, and then physically they rotate the mechanical axis, and then they use this one as something power to use the pump and mills or to grind something grains or something multifunctional stuffs. Okay, the largest machines were actually 20-meter towers with 4-bladed, which is one more blade bigger than the three-blade wind turbine. But at that time, that was most largest one in almost the 19th century. It's 23-meter diameter rotors. Now you remember that it's almost over 100-meter diameter rotors used in the world. Right, windmills, actually, you know this one is old-fashioned one. There is the typical blades like windmill blades, and after then the brake wheel. Actually, you know, why do you use brake wheel here in this case? Because it's, if you have strong wind, like extreme wind is coming, then you have to stop the windmill. Okay, that's why they need brake. Okay, and then there's wind axis. Actually, you need to use this mechanical rotating energies by grinding the, you know, like, how can I say, food, the grains or wheat or something like that. Okay, so on the under this axis, this is grinding stones, and then make a grinding all the grains, and you will collect all the, you know, the food on the bottom. Okay, right. So just want to see more history again here. In 1908, there were 72 wind-driven electric generators operating in the US from 5 kilowatts to 25 kilowatts. So around the time of World War I, American windmill makers were producing 100,000 farm windmills each year. Mostly they use it for water pumping, and then provide water every time, grow the grains or wheat or whatever. Okay, well, that story is just like that. It's more people get approaches is the natural wind case, and then they utilize it by using something like two such called windmills or wind turbines, and then they install more and more. They increase more wind farms in their sector, okay, their area. So mostly modern horizontal axis wind generator was in service in Yalta, and that's the USSR, and now it's Russia. And this was 100 kilowatt generator on our 3-meter tower connected to the some 6.3 kilovolt distribution system. Oh, here they use capacity factor terms 32%, which is generally used to assess how this turbine used in the reality. Okay, and then in 1941, the first megawatt class wind turbine was built in US, and they call this one a Smith-Putnam wind turbine, and only ran for 1,000 hours before suffering a critical failure, and then they didn't use this one anymore. So this is one of the most earlier megawatt class wind turbine, which is very, you know, representative fact in that case. Okay, right. Right, so after then, America, they built more and more. First, the utility grid connected wind turbine, and then anti-nuclear protested in Denmark, and then there's another micro turbines like 22 kilovolts, something like that. Now, many companies, they developed and then built their own wind turbines, and these companies include like General Electric, GE, and Vestas, Gamesa, and then so many manufacturing companies coming now. Okay, right. Right, in this position, well, in this time, in this slide, I would like to ask you what actually you see in the figure. Well, this is actually, you know, kind of a lecture, but I want to ask you what actually can you see in the figures, which is very famous paintings of Monet in 1871. Actually, you see the figure that's very weird point in the paint. Okay, so you see the windmills looking at from the right side to left side, but you can see in the middle of the figure this boat had a tower, the master tower in the middle, and that's you see the plaque on the top. So you see here, you easily guess the wind is coming from right to left. The problem is the windmill is looking at from right to left, which means the wind is coming from left to right. Okay, maybe Mona didn't know about this fact, something like wind blowing or fluid dynamical stuff in that area. Okay, so that's why we think the wind is, we have to consider the wind more carefully to visualize the flow on something like, so you have to use the energies properly in reality. Right. Okay, well, this one shows you some concept of windmill-like device, something like organs described by Hero of Alexandria in the 1st century AD. Okay, which is popularly used at the time to play organs in the field. Okay, right. As I told you earlier, the earlier windmills was made by the one person, maybe the people in Persian, and which is located in the Ne. Okay, this one is actually now is between Persian and Khorasan in Iran. Okay, right. As you can see, very simple design, and this one we call that drag type wind turbine. Okay, actually the axis, this is vertical axis wind turbine. So the main axis located vertically in the middle of the wind turbine, and the wind is coming in the one side in the half of the vertical wind turbine, and then blow it and then make rotates in the one side. Okay, and on the bottom, as you can see in the bottoms, and there is grinding stones, and then this generates kind of ground powder from the grill, from the grains. Okay, so old-fashioned wind turbine, and actually they utilized the wind properly. Right, this is another type of windmills. Actually they use, China, they use this vertical axis Chinese windmill, and they use 8 junk slash sails on the side, and when wind flow, they sail and they deflected and generate kind of torque, and in the circular circle here, and then generate the different the rotational moments, generating the torque in the middle. Okay, well, different type. And then this one is also, there is something horizontal axis wind turbine steps. The left-hand side, actually, you see the windmill, typical Holland windmill style wind turbine. And then the right-hand side, all the fashions, the earliest known illustration of horizontal axis windmill. And this wheel is supported on the post. That's why they call this one post mill. Okay. Now this bracket type to use the windmills in old ages. So if you look at more carefully the windmill used at the Vril, UK. So the earlier design I told you in the earlier slide, there is a blade and then brake and then an axis and then grindstone in the bottoms, and then such like that, because it's that rotational movement generate kind of torque. The torque generate kind of force on the bottoms to make your food properly. Okay, right. This is post mill, and then this one is Dutch tower mill. Seems like this is the similar shape of the tower. That's why they call it the Dutch tower mill. So based on this tower mill, consisting of so many functions in the tower, like cap or this is actually the just cap. And then the dust floor actually collect the dust, never, to make any mess onto your mail or something. So this one actually the dust floor, okay? Sorry for that, dust floor. And then on the bottoms, on the next floor, the wind floor actually collect all your grains. And then stone floor actually grind all the things, all the grains. Then mill floor collect your, flowers actually on the bottoms. And then another levels of your floors, actually the different way around to use it, like bedrooms or living rooms to sell or your grains on the bottom, okay? Right, well, this one is the details of that one. I told you that dust floor, MP floor, stone floor, and the mill floor. Actually, there is a different functions how they use in the old ages. Right, and European windmills has something applications like provide water from the river and then rotates forces actually pump all the water from the rivers to the other place. Okay. Right. Well, this one is some design used in America, and they call this windmill, this device as a windmill. And actually, they use this pumping water. So actually, water is the density around 1,000 kilograms per cubic meter. So it's really, really heavy to provide compared with the air. So actually they needed kind of the tremendous torque to provide the water from the ground to the top of your living space. So what actually they use for their living, actually they use multi-bladed windmills for pumping water. Once I visited America last several years ago, I visited Texas, and the person in charge in Texas University shown me to look at their site in the field. Actually, Texas was really a rough countryside area, and then this is pretty nice to look at the small scale wind turbines in the field. And then they brought me Texas Tech playground for American footballs, which was pretty nice. Look at on the overlooking the playground. Right, and I visited the American Wind Power Center. Actually, this is park, and then they deployed the Vestas. I don't remember the size of the wind turbine. Maybe around the 700 or 500 kilowatt wind turbine, and then there is a small scale numerous wind turbine windmills in the field. So there are several kind of windmills. Mostly they had some multi-bladed wind mills on site. Right. Well, this is as I told you earlier, one of history in U.S. to have the one representative megawatt size wind turbine called Smith Pusan wind turbine, which was built 1941. So they had only two bladed in the site in the wind turbine, and then they built all over the how can I say gearbox and what was that? Generators and towers, whatever, all the things. Actually, they were built in Vermont and the USA. Right. Well, nowadays they use something like mostly well-developed wind turbines, like 2.8 megawatts. That was still very old, that was 2000s, and then Enocons 2007s. So nowadays, you all guys looking at these kind of wind turbines in the field, and mostly now NZ develops this 12 megawatts commercial wind turbines. Actually, now many people are looking at more bigger one like 20 megawatts. and there's on still research now. Okay, right. And then the wind turbine standard configuration, actually they have the rotor, and then train, the drive train to transfer rotational force to the electric force, something like that. And then they need the 3 rotor blades, and then in order to change directions of wind turbine, they need a yawing system, yawing mechanisms. Okay, right. Well, I would like to introduce more information we built. Still, this one is old fashions in the 2013, and we have some big island called Jeju. We have an island Jeju in our country, and then this is really popular area to build wind turbine and wind farms. So even now, they still operate, still making more wind farms under constructions. So this is some example they are making progress to build wind turbines in our country. There's other place. Oh, this is actually the Jeju Island. This island Jeju, and this, as you can see, then the arrows. You can see there are several places, and in the middle of this island there is Mountain Hala. I think I remember it's almost 1,000-meter height. It's over than 1,000. I don't remember actually. Sorry for that. And look, mostly the very nice view around these islands, but this is very close to the mountain. There's pretty nice wind energies, and even in the coastline, there's pretty nice wind around this island. So many operations ongoing in this island. Right, there's some more places you can see in our country. There is several places to be building the wind farms. Actually, the one representing the place is Yeongdo on the right hand side of our countries. It's the east coast, because the east coastline will be the perfect place to build the wind farms in our country. So as you can see on the right hand side on figures on the maps, which is called the eastern coastline, and there's so many wind farms and the wind turbines has been built in this area. Okay, right. There's Taebang Mountain. Firstly, this is Yeongdo Mountain, Yeongdo wind farms, and then this one is the Taebang wind farms, and then even more than this one, so many wind farms around our country. Right. I want to skip this one more. I think this is old-fashioned one. So starting with their installations of Vestas, Gamesa, and then so many other wind turbines and wind farms was built in this area. Right. Well, this is now is they changed their policy. Not only they built the wind farms in the eastern coastline. Now they changed their policy to build them in the west-southern coast, and they just cover all the coastline of South Korea. Yeah, well, this is old-fashioned one. Actually, very similar nowadays. The global cumulative capacity of wind turbine. Well, this was 10 years ago one. Still, this growth is going on more and more. Okay, even now Europe is very popular, but it's even Asia one, maybe China. They have built these wind farm more and more nowadays. Okay, right. I want to skip this one. It's old-fashioned one. Okay, well, even the market focused is still more, ongoing in the market. Okay, I want to skip still. We don't have time actually. There's just 10 wind turbine suppliers report, and the one popular one, GE, and Vestas is one of a kind. And even nowadays, India and China, they have a more experience on the track record to build wind farms in the field. Okay, well, we'll skip this one anyway. Sorry for that. I've just skipped this one. Right. Well, what about the future of wind farm? Actually, well, we need more future technologies to utilize wind energy. And not only this plastic one, we need more advanced technology to use wind, turbines or wind energies. And sometimes there's strange problems to develop wind turbine or something, but actually what we have to do, we need to have new technology like LED wind turbine or hybrid wind turbines or hybrid energy power plants or multi-bladed wind turbine, something like that. Maybe this can be your choice and then your duty to develop it. Okay, right. Well, I don't want to go furthermore anymore. I think I have 30 minutes to go. So I think just want to close my presentation now. Thank you. Hello.
Hello. Thank you, Professor Lim. Now,
Wow.
please, this time open to all the participants if they have any doubt or any question they can ask from Professor Lim.
Yes, dear participants, you can clear your doubts or any question related to future technology in the field of wind turbines.
May I ask some questions, sir?
Yes,
Hi,
sir,
yeah.
welcome.
Okay. I am SP Meher from Arjabad Institute of Technology, Delhi. So first of all, it is a very good afternoon to you, sir. As in Korea, it is a afternoon session. So very good afternoon to you, sir. And the presentation is very wonderful regarding the wind turbine. The question is, there are so many cases of bad incidents coming with the wind turbines, and that is a main ecological problems. So how we can overcome from such problem?
Oh, I just hear that from your voice. There's problems and instance installation steps. So do you want me to tell you kind of the installation problem of wind turbine or wind turbine problem of operation?
My question is about bird incident. Birds, so many birds are coming across the turbines blade, and there is incidents are occurring at large numbers. And birds are the main factor of the ecological systems. So how we can overcome this cases of wind turbine, reduce the cases of bird incidents?
Well, I'm sorry for that. This is a bird. What is the bird instance?
Birds, sir, birds.
Birds.
Yes, sir, yes, sir.
Oh, sorry for that. Yeah, bird. Yeah, actually, the bird instances usually happen for the blade. The number of blade is less than 2, not actually 3. This was reported so many times, like bird strike. This happens only in 2 or 3 bladed. Oh, sorry, 1 or 2 bladed wind turbines. But it is to avoid. Actually, bird strikes happens, but actually the wind engineer increase the number of blade to 3, and then this lose kind of power. However, for considering the natural circumstances, then the 3-bladed rotate less speed and then try to reduce the bird strike. So there's one possible things. Well, one representative example was in the U.S. Actually, there is a big wind farms in U.S. and they avoid this kind of bird strike properly. Yeah, we do not have any the really big wind farms in our country. However, the bird strikes only happens less than the less than two bladed wind turbine. Okay, I hope this one gives you the answer.
Okay. Thank you, sir. Thank you very
Okay.
much.
Sir, myself Mayank Pandey. Hello, myself
Hello.
Dr. Mayank Pandey from Harvard Institute of Technology. My question is, when we are using wind turbine on the big balloons, where when there is no wind pressure on the ground, we are using balloons. Okay, so can we just bring the electricity from that particular wind generator to the ground by some wireless method or not? Because they are using physical wire to bring the electricity from the wind turbine, which are there installed in the balloon, and they are bringing the electrical connections through that particular stay wire, we can say, to the ground. So can we do it by some wireless method or not?
Right. If you telling me kind of a new technology of the balloon wind turbines, is it the
Yes, sir.
okay? Well, now this is new technologies is coming up because you said it's a balloon wind turbine, and then there is some research sector they are working on the balloon wind turbine, and then they told us they actually shown us the balloon wind turbine will be one of the leading technologies in new wind turbines, maybe several hundreds next several decades. Actually, this one will be located in the higher altitude, higher height from the ground. So these balloon wind turbine utilize more faster, more strong winds in the air. So which is pretty nice. The problem is, in order to use these floating, how can I say, balloon wind turbine in higher altitude, then the problem arises over the weight over the, what was that, the cable. Actually, cable deliver the power sources, and then this one hold all over the balloons properly. So this so happens, this goes with a big problem of difficulties to deliver the electricity as well as hold the whole system. So,
Okay.
well, yeah, this can be kind of, pretty nice idea, but still need some research or some work to do.
Okay, thank you, sir. It's clear, and your presentation was very effective. Really.
Okay, thank you.
I do appreciate. Thank you, sir.
Thank you. Yes.
Yes,
Yeah,
Hitesh.
Professor.
Yeah.
Professor.
Good morning, sir.
HEECHANG.
Yes, Hitesh Bhargav, ask your question.
Yeah. Good morning, Chang, sir.
Right.
Sir, nowadays we are preferring a hybrid or dual purpose system rather than standalone system. So what are the prospects and problem of solar hybrid wind technology?
Right. Well, that's just, there is a problem of one singular renewable energy device, such as wind turbine or solar panel or geothermal or something. Because in order to get energy from the wind, you might have kind of, problem against or continuous energy supply. And you see, wind turbine generate wind, generate actually the electricity from the wind, but we expect wind coming all the time. However, the wind cannot, comes every day, every hour, every minute. Sometimes it comes, sometimes it do not come. So what you expect here, you have to utilize this one evenly by using the other energy sources like solar panel or solar energies or geothermal and the other stuffs. So we call this phenomenon like intermittency of energy. You have to get this energy more constant by using extra energies. So if you say solar panel or solar energies combining with wind energies, we call this one hybrid energies, which is very useful to use it continuously for the so many undisturbed the villages or some kind of places. So hopefully this one you want to get answer like this.
Thank you, sir.
Okay.
Yes, now Harijan Das, sir.
Yeah, Professor Lim, I have a
Hi.
question. The material composition of the blades, what in South Korea you have found the best composition for a maximum end of life? And what are the kind of erosions you have faced in the blades?
Right. Well, this is really, highly technical questions I have to reply. Actually, no, you have to use composite material to build a blade, actually. So many well qualified company to make or to build the wind turbine blade need to have kind of, very nice ingredient, and that this one must be certified from certified institute in Korea as well as the Western country. So they actually give you some permission to use this material to build blade. But actually this is really hard. Actually, you can build it. Problem is you need a certification to provide the blade. So based on this idea, what you have to follow to make a blade is IEC 61,000 61400 rules to satisfy their requirements. In terms of erosion steps, and in Korea, there's a variety of erosions like the sand or the dust or water and salted waters. Any kind of things can affect the erosion on the blade. So what you have to consider to make some kind of blade for certifications, you have to look at firstly IEC series to justify their requirements. So I hope this one answer you.
Thank you, sir. Thank you.
Yes,
Hello.
Professor
But the end of life, what is the end of life you presume for the blades which are being used in the coastal areas?
Oh, and all right. Oh, wow. Yeah, raising difficult questions. Yeah, well, yeah, actually that one you must use, I think, is the composite material, as I told you. And well, if you say type of the wind turbines like the horizontal axis wind turbine, but I'm not sure, the end of life actually the wind turbine like. So we'll think about more. Thank you.
Sir, related to this same thing, I would like to ask, what is the safe wind speed which these wind turbines can handle? Because in most of the coastal area, we find sometimes cyclones are coming with wind speed of 150, 200, 250 meters per hour.
Well,
So how they are safeguarded?
yeah, most wind turbine only support the wind speed around 25 meters per second. If you get over 25 or 30 meters per second, then the support or some other blade, the other steps cannot, endure all the forces from the extreme wind. So normally, as I told you in the presentation, normally stop the wind turbine blade or the rotations of the blade at over 25 meters per second. So they need brake in the wind turbine systems. So that is the way why you have to use brake in the system.
Yeah, but related to the strength of the wind blades, whether it is not operating for power generation, but it will withstand that around 250 kilometers per hour wind speeds.
Well, yeah, well, that is something like the requirements to support the strong wind speed. And this again, this is IEC the series. There is something written rules to endure this higher speed level around 50 or 100 meters per second. But it's just like there is kind of safety factor to endure the speed. Maybe that can support maybe 3 or 4 times bigger speed can be supported, but I've not really remembered what number of the speed can support the wind.
Yeah, thank you, sir. One more clarification. We were just talking about hybrid applications
Right.
with reference to solar. But my query is that a lot of we have agricultural applications for solar drying. So same thing can also be tried near the windmills, nearby area, because of the high wind velocity circulation, may be used for drying of agricultural products.
Well, yeah, what you mean is water turbine or something like that?
Now, I want to ask about drying applications, agriculture products, dehumidify we have to for long storage. So high wind velocity near the wind turbine, can it be utilized for these applications also, secondary applications?
Well, maybe yes. Yeah, well, still I cannot catch the right questions from your side. Sorry for that, Professor Amitel.
Yeah, I think not much studies have been done in this field, but that is also one potential area. Now, Professor Rajkumar Singh is also want to ask something.
Yeah.
Good morning, Professor He. I am in mechanical engineering department at DTU. My question is, or some doubt or clarification is not from technical perspective, but it is more from policy perspective. I want to know from you or your observation, if you have framed, that what policy framework led to Korea into a sort of developed country. Now they have almost no poverty. So what policy they have adopted which led to this type of situation?
Well,
in your opinion?
Yeah. Well, in Korea, actually, they have something like policy to install the renewable energy tools or the devices in South Korea in terms of the agreement inside of or between countries. They call it REC or RPS. That's renewable portfolio some things like that in between countries they should exchange or to make agreements to reduce the carbons properly. So the RPS is one of the rules they have to use. So in South Korea, we have agreement with other the Western country starting 2%, starting at 2010 or 11, with 2% of renewable energy installations must be made from the electricity generations from the fossil energies. So from the beginning with 2%, now I think 10% over there, the production rate of the electricity, this one must be made each year. And this one, if our country break this one, then we probably get penalty. So if you consider kind of why we have to install the renewable energy, or which scheme or which policy we have to consider the renewable energy, this kind of scheme is one of a kind. And then another way, if you say the politics, maybe head of or maybe some groups in the higher groups in your country could have a kind of big power. Maybe they forced country, how can I say, the power generation sector to install the more the environmental friendly devices like wind turbine or solar cell installed in the country. So I think I'm not sure whether I can I reply properly. Firstly, there is rules between countries, and then based on that rules, you have to install the renewable energies. And the other one is politics. If politically many people are agreeing to install more renewable energies, and then well, they have to control all the things and steer these companies or the relevant industry installed more bigger number of wind turbine or the solar cells in the field. I'm not sure whether I replied it. So, is it answering you properly, Professor Raj Kumar?
Thank you, sir. Thank you very much.
Okay. Yes. Right.
Yes, anyone else?
Okay.
Can I ask?
Yes, welcome, Jen sir.
Okay, good morning, Professor Lim. I just want to know, I have seen in India so many windmill, big size windmill. They are always horizontal axis windmills. But I have seen some smaller size, they are vertical axis. So what is the problem that we are not going for the big size windmill in vertical axis?
Well, that's also technical issues because it's a vertical axis wind turbine usually have the bearing problems, and because of the heavier weights becomes more serious to support all the systems from the bottom. Actually, when you're rotating, moving part stay in the bottoms, and the bearing part have difficulties to move easily during their life expectancy. If you put this one in the tower like horizontal axis wind turbine, there must be some mainframe, and there is the main axis on the top here, and then that rotates properly by using the heat exchangers together with the proper bearings, so many bearings. So this is more or less temperature effective or wearing effective or the stable. There is a very great stability to support the rotational moving part. So in order to increase your capacity more, what we have to do, change the type, the wind turbine type from the vertical axis to horizontal axis wind turbine. And then actually that's why you cannot get the higher capacity of the vertical axis wind turbine in the field. Hopefully this one answers you.
Okay, sir. Thank you. Thank you very
Thank
much.
you.
Yes, anyone else? I think now no one. Yes, somebody?
Yes, thank you, sir. Thank you. With this,
Thank you.
the session of Professor HEECHANG Lim come to an end. And I am thankful to Professor HEECHANG Lim that in a short notice he was able to cover his valuable guidance.
Yeah, sorry, I forgot that. I'm sorry for that.
Sorry, sir.
Yeah.
Also, if I hear so many intellectuals are present here in the this panel, so I recommend all the faculties that they recommend good student. I share in the chat box the link of Professor Lim's lab. So if they have any this promising student who should have career abroad, so he or she is welcome in Professor Lim lab from my side. And also Professor Lim support the student and he never feel that he is away from home. So he is ready to take care of student, and so I recommend all the faculties to suggest his best student, Professor Lim lab.
Thank you.
Yeah,
Usually
that's a very
nowadays,
nice opportunity. Very nice opportunity available with Professor Lim at Pusan University. So anyone interested to pursue or their well-known contacts, they may contact Professor Lim. And due to pandemic, we are having online session. Otherwise, we would be very happy to invite Professor Lim. He has been visiting India frequently, and we soon, when this pandemic is under control, Again, we will be meeting with Professor Lim and having direct physical contact meetings, have a cup of tea together and discussions continue.
Thank you.
So,
May I have one final word in
Yes,
front of you? Well, it will be my great pleasure to join and present my work in a well-known conference or the symposium. And actually, nowadays, I'm working on the AI or deep learning, the method or the project, as well as the wind turbine area. So if you guys are interested in my laboratory or my work, you can contact actually the Professor Bhupendra Chauhan, if possible, and then he will guide you to me properly. And then that would be nice to meet you actually today. And really my pleasure. It's really good time. Thank you very much indeed.
yes, yes. Thank you, sir. Once again, thank
you once again.
One announcement for all the participants. Very soon, within 2-3 minutes, we are going to send the feedback form. Please give your true feedback for our future improvement in organizing such programs. Give the areas which you want. There are the areas of interest so that we can cover those topics in